Hello class, this is the last video for the week and then for the semester. Section 5.5 talks about the substitution rule. Okay, so our objective is to understand this substitution rule and then apply it to evaluate both definite and indefinite word integrals. Okay, now I want to remark that this, if you remember, when we were considering differentiation and then the composite functions, okay, the composite functions that we couldn't differentiate something like what, say square root of um say x plus 2 x cubed, something like this, because this is a composite function. Therefore, we use the what, we use the chain rule. Now, in the same way, when it comes to what integrals, right? And then you have a function that is of involving what, a chain rule. So sorry, a composite function like that. Okay, then we use what we call the substitution rule. So in other words, what we're going to look at today is what, the reverse of what, the chain rule. That is, what is the antiderivative that if you use the chain rule to differentiate the integrand, you will get that. Okay, if you differentiate the what they call it, the antiderivative, you get the what, the integrand, which is the what, the chain rule. All right, here consider, because of the fundamental theorem, it is important to be able to find antiderivatives whenever we integrate functions. Okay, but if you consider this function right here, 2x times the square root of 1 plus s squared, okay, it is going to be such difficult. There's no formula that we have considered in section 5.4 that could directly help us to what, to integrate that. Okay, to find this, okay, to be able to find it, we have to introduce something extra. Okay, and that is something extra is what, we have a new variable we want to call what, a u, and that will be the, so we're going to make a sum substitution. All right, so how do we, okay, find the antiderivative of this function? Well, we introduce a u. All right, so we look at this function right here, this the integrand. All right, now this part is 1 plus what, x squared all raised to what, 1/2. So this is what, is a composite what, composite function. All right, and there's an extra, okay, 2x, but that will happen when I differentiate my substitution. All right, so if I look at the inside function, if you want to call the inside function, right, then we will let the u equal to that 1 plus what, x squared. So you have your u, which is what, 1 plus s squared. Now let us try to differentiate that. What's the derivative of the u with respect to what? So that is the derivative of 1 plus what, x squared. And this gives me 2x what, dx. All right. So how do we proceed? This is the extra something that we talked about in the previous slide. Okay. So this is ds. Therefore, what we have there is actually what, du. Okay. Because we have du. Okay, this is actually 2x. So du is what, 2x what, dx. Okay, 2x ds. Now let us go back and pick the integrand and see what is happening there. We have 2x times square root of 1 plus what, s squared dx. Now this is the same as the integral, okay, 1 plus what, x squared, then 2x dx. So if I use the u in terms of u, basically what is here is my u, du. Okay, and then over there I substitute my what, my u. So the whole thing becomes, if I do it on this side, the integral that is given, the 2x times 1 plus x squared with respect to x, in terms of u, will be what, the square root of what, u times what, du. Okay, because My du is the whole of what? 2x times dx, and then have a square root. Therefore, this is the same as the integral u raised to what? 1/2 times what? du. So this conforms to one of the formulas in the table, and this is the using the power rule. Therefore, what is the antiderivative of this? It's going to be u raised to 1/2 plus 1 over 1 plus 1/2, or 1/2 plus 1 plus what? Plus a c. Well, what is that? This is going to be u raised to a 3 over 2, and then divided by 3 over 2 plus c, which is equal to 2 over 3, then u raised to what? 3 over 2 plus c. Then we substitute back, okay? Substitute back into that, then that should be, so your integral, there's a 2x 1 plus x squared dx is equal to 2 over 3. What is my u? 1 plus x squared raised to 3 over 2 plus what? Plus c. So therefore, this whole thing is my antiderivative of that function. So it means that if I want to check this is correct, then I have to differentiate the what? The capital F of x to get that expression there. Okay, so let's try that. Okay, so we want to check our answer if that is correct. See, we want to differentiate what is there. Okay, I have the answer there, but I want to do it together with you. Okay, so if I differentiate this, I have what? 2 over 3. Then if you differentiate that, I have what? It is 3 over 2. Then times 1 plus x squared raised to 3 over 2 minus 1, which is 1/2. Then times, I'm using the chain rule, times what? The derivative of 1 plus x squared, which will be what? 2x. All right, so now let's simplify that. That is what? 1 plus x squared raised to what? 1/2 times what? 2x. Okay, now is it not what? The 2x, then square root of what? 1 plus what? X squared. All right, so you can see that this is my small f of x. Therefore, the derivative of the antiderivative, okay, is equal to the what? Your integrand, as that. Okay, so we're going to use this approach to solve some problems, because whenever I have composite functions there, it's not straightforward to use any of the formulas. You have to manipulate it using the substitution rule. Okay, so here comes the rule in its entirety. Okay, if u is a function of x and is differentiable, okay, whose range is an interval I, and the f is a continuous function, then the derivative of the composite function f of g, which we say the f of g of what? Of x, like that, it times, so if the integrand is what? A composite function times the derivative of what is the inside, then that's when we use the what? The substitution rule. Okay, in the previous example, you will notice that it was this, sorry, we have the integral, we have 2x, okay, 1 plus x squared dx. So the question is that when do I apply the substitution rule? I look at this integrand, okay, now if I differentiate that, I get what? The 2x, which is right there. If we differentiate 1 plus x squared, I get the 2x. And so we could see that once I have that, then this is of this form. It is a f of x, f of g of x times the derivative of g prime of x. And then that's when I say that, okay, I can use the u, the substitution rule, and say that the u is equal to 1 plus what? X squared. Okay. So if we put it in a perspective, what we are saying that, notice also that the u is a function, then if we differentiate the u, remember when we differentiate the u, in this example, we had what? 2x what? Dx. Because it's supposed to be du dx equal to what? 2x, and then when you multiply through, you have what? It's supposed to be du dx is equal to 2x, and therefore your du is a 2x ds. We multiply through by what? Dx. There you get that. Okay. All right. So let's consider this example. Say that before we do that, I said, thus, the substitution rule says that it is permissible to operate with what? Dx and du after integral signs if they were both differential. Okay, so now I have this function. I have x cubed, that's my integrand, times cosine of x to the 4 plus what? Plus what? Plus 2. Okay, now I see that, look at this, this is a composite function. Now if I differentiate this function, let's see, if I differentiate that function, x to the 4 plus 2, I get what? 4x cubed dx. See that? I get 4x cubed. Now this part, I see that that is right there. Okay, so that tells me it is of the form f of 4 g of x, g prime of x dx. Okay, so then I can rewrite this as what? This is integral cosine of what? X to the 4 plus 2, right? Times what? X cubed what? Dx. So if I'm using the substitution rule, what is my u? Okay, in this case, I'll let my u be equal to what? X to the 4 plus what? Because when I differentiate the u, I have the term x cubed, which is in front there. Okay, I don't have to get exact. Here it gives me 4 of that, but I can solve for that expression. So what is du? Du is equal to what? 4x cubed dx. Then divide both sides by what? 4 and both sides by 4. So that means that this expression right here, I have what? It's going to be the cosine of the u. Okay, let me just, before I substitute the u inside, I have what? Cosine of what? Of x to the 4 plus 2, and then I have x cubed d what? Ds. Now this whole expression is du over 4. And then I can have my u over there. And that gives me the integral, okay, the elongated what? A stretch s will give me cosine of what? Of u times du over what? Over 4. Now, whenever you have this, you can bring the 4 outside, okay, and write this as cosine of what? U du. Well, what is the antiderivative of cosine? That is a function. When I differentiate, I get cosine. That's going to be what? Sine. All right. So this will be 1 over 4 sine of what? Sine of u plus what? Plus c. And then substitute the u back. You have 1 over 4 sine x to the 4 plus 2, then plus what? Plus c. Okay, so that will be my what? My answer. So you see how I picked the what? The u. All right. So you have to check that it conforms to the spot. Okay, this is your du. All right, let's take other examples. Here they give us the u and said that let's use the u given. So we are lucky. Exercise number 2. Some they don't. Some this one it is given. This is my u. So what I do is that let me differentiate u. It's got minus 2x dx. Okay, minus 2x dx. So look at this expression here. Let's write our original functions. What? X e raised to minus x squared d what? Dx. Now this is the same as the integral e raised to minus x squared then times what? X dx. So you see that this expression is right there. So I can solve for that. So it means that I have what? Du over what? 2, that is negative, is equal to what? X dx, which is right here. So this expression in terms of u becomes what? Integral e raised to what? U. Then times, what is that? Is minus du over what? Over 2. Now, which is the same as saying the integral u e to the u minus, there's minus there, can bring it outside, and then the u over what? Over 2. Well, we can bring the constant 1/2 outside and write it as so e to the u, and then what we have for the u. So by the way, when you antiderivative of e to the u is e to the u. So this will be minus 1/2, okay, e to the u, then plus what? Plus a constant. Okay, so that gives us minus 1/2, okay, e raised to what? Minus x squared plus what? Plus c. Okay, so that gives us the answer. Okay, now because, why did they say that use the u equals negative x squared? All right, which is this exponent. All right, because when I differentiate, I have the x times the x there. All right, now let's take another example. Okay, this is similar to, okay, the u is not given. So in this case, what to be my u? You're going to let u equal to what? The 1 minus what? X squared. So let's differentiate the u. You have for minus 2x dx. All right, so then the integral x times the square root of 1 minus s squared dx is written as what? The integral of 1 minus x squared then times the x dx. So this x, you can put them together so you know what we are looking for. So what does that mean? It means that the u over 2 minus is equal to x times what? Dx. So then in terms of u, it will be integral, then the square root of u times minus the u over what? Over 2. And that gives me minus 1/2, the integral u raised to 1/2 times the u. So let's find the antiderivative of that. That is minus 1/2, okay, u raised to 3 over 2 divided by 3 over 2, then plus what? Plus c. Okay, and what is that? This is what? Minus 1/2, okay, and that gives me times 2 over 3, u to the 3 over what? Over 2, okay, then plus c. So that is equal to minus 1/3, okay, and then u 3 over 2 plus c. Well, by what is u? Just plug it back. U is what? 1 minus x squared raised to 3 over 2 plus c. So that is my what? My general antiderivative. All right. So when it comes to definite integrals, we use the same thing, except that we can change the limits, all right, or we'll substitute back and use the original limits, and I'll show you in both ways. All right. So let's go to definite integrals. All right. We want to evaluate this. Okay. Evaluate this using the definite integral. So I'm going to do this and without changing the what? The limits of integration. All right. So what is that's my u here? Well, that's that's inside function. So that is what? 3t minus 1. So let's differentiate u. We get what? 3 dt. Okay, but here we don't have 3 outside there. We only have what? Dt. So dt, divide both sides by what? By 3. Okay, so then the dt is equal to what? Du over what? Over 3. So this expression here, okay, I'll first consider the indefinite integral. Okay, so let's find the indefinite integral of that. So we have for 3 t minus 1 raised to what? 50 dt. This is, in terms of u, will be what? U raised to what? 50. Okay, du over what? Over 3. All right, so let's find that. That is supposed to be 1 over 51, u raised to what? 51, okay? But there is what? 1/3 outside that. And then, okay, so that is 1 over 51 times 3. It is 153. U raised to what? 51 plus what? C. Now, when we substitute back what we have there from 0 to 1, 3t minus 1 raised to what? 50. Okay, then this is equal to 1 over 153. What is my u? U is what? 3t minus 1. And then we substitute, this is raised to what? 51. We substitute what? 1 and then what? 0. So that is what? 153. Okay, 1 over 153. Okay, when you substitute 1 into that, we have what? Be 3 times 1 minus 1 raised to 51. Okay, and then minus 153. All right, and then we plug in 3 times 0 minus 1 raised to what? 51. Okay, so this gives me 153. Okay, we can bring that outside, and then this will give us 3 minus 1, 3 minus 1, which is 2. So that's 2 raised to what? 51. And then minus, if you have minus, that will be plus 1 raised to what? 50 or 51, because that's odd. So basically you have 2 raised to what? 51 plus 1 divided by 150, what? 153. Okay, so you can approximate that. So we see that to find a definite integral, I first consider the word indefinite integral. Okay, get my antiderivative and plug in back the u. Now I evaluated it at what? The limits given. All right. Now the next theorem will allow me to do the same thing, but I will change the what? The limits of integration. Okay, I'll change this in terms of u. I'll find the limits of integration so that I don't have to plug it back the u and evaluate. All right, so this says that if g prime is continuous function on that interval and f is continuous, okay, on the same range, then this is given by what? The g of a. See that the limits of integration changes from what? A and b to what? G of a to what? G of b in terms of what? In terms of u. Okay, so I'll do the same problem, right? But I'll change the limits of our integration. So again, I'll let my u equals the same 3t minus 1. Now, this says that when t is equal to 0, what is u? All right, it means that when t equal to 0, then u is equal to 3 times 0 minus 1, which is -1. Okay, when t is equal to 1, then the u is equal to 3 times 1 minus 1, which is what? 2. So this becomes the what? The upper limit. Okay, upper limit. And that becomes the lower limit. You see that? Okay, so let's do the same now. What happens that this from 0 to what? 1 of what? 3t minus 1 raised to what? 50. The t now becomes the integral from -1 to what? To 2 of u raised to what? 50. Okay, 50 d what? du. Okay, by the way, let's just find the du right there. Du is what? 3 dt. So divide both sides by that. This is du over what? Over 3. So then this becomes 1/3. All right, 1/3 the integral from -1 to what? To 2 of u raised to what? 50 du, like that. Okay, so then this is equal to 1 over 3 All right. This is 1 over 51 u raised to 51. And then we evaluate it as what? 2 and then minus 1. So this gives me, okay, that's 1 over 150, what? 153, which is right the same thing, because 3 times 151. So 51 is 153. Then this will be 2 raised to what? 51 minus 1 raised to what? 51. Okay, that is 1 over 153 in times 2 raised to what? 51. And then that should be plus, because 51 is odd. If you raise the negative, then that should be what? 1. Okay, now what is that? That is the same as the answer what we got right here. Okay, the same answer as we got the answer, but we have fewer what? Steps. Only thing that we have to convert, do the conversion, okay, from this limits, original limits, to what? The limits in terms of what? U. And we all get the same results. All right. Now, there are certain functions that are symmetric. If an even function is symmetric about the what? The y-axis, and then the odd function is symmetric about the origin. Okay. So when that happens, and you are integrating something from the limit, depending on the limits, if it is the function is odd or it is even, there's a way we treat those. So let's consider them. Okay, so the following theorem uses the substitution rule for definite integrals to simplify the calculation of integrals of functions that possesses what? Symmetry what? Properties. Okay, so suppose f is a continuous function on the interval from -a to a. Okay, if f is even, that is when you substitute negative x into the function, you get the original. Then from -a to a, because they will cover the same area, it is same as take half of it and multiply by 2. Now, if it is odd, then it's going to cancel out. And so the answer will be what? 0. Okay, in a picture or in a diagram, this is illustrated here. So if I have a function, I'm integrating it from what? -a to a. It has the same area to the right and the same area to the left. Okay, as you can see, because if an even function is what? Symmetric about the y-axis. So that is why I just consider just half of it, that area, find this area and multiply it by what? By 2. And that is what I have here. Now, if f is odd, okay, this area and that area are the same, but one is positive, the other is what? Negative. And guess what? They will cancel out. That is why the answer is what? Answer is 0. So for the cases where f is positive and even, part A says that the area under y equal f of x from -a to a is twice the area from a to what? From 0 to a, if it's symmetric. So we know that an integral of that definition can be expressed as the area above x-axis and below the function minus the area below the axis and above the what? The curve. Thus, part B says the integral is 0 because the areas cancel out. Okay. All right. So here's an example. Is it now? I only apply this when I have what? -a to a. So -2 to 2. So then I need to check. This is my f of x. Okay. X to the 6 plus 1. Is it even or odd? So I substitute minus x into the function. Okay. It's even, so it's going to be the same thing, plus 1. So this is equal to what? F of x. So the function f is what? Is even. Now, if it is even, I have this, I just integrate from 0 to 2, that's half of it, and multiply by 2. Okay, so find the antiderivative of x to the 6 is what? It's 1 over 7. Okay, it's 1 over 7 x to the 7 plus what? Plus x. Then that gives me, I substitute what? Evaluate at 2 and then 0. This is minus just what? 0 minus 0 plus 0. Because if I substitute 0, I get 0 for each of this. So I get 128 over 7 plus 2, then times 2 gives me what? This answer. Okay, so that I don't have to do this. Okay, this is the same as saying that it's from -2 to what? To 0 of the function, plus you integrate from what? 0 to what? To 2 of the same function. And you add them. Why don't we just cancel one, and then that shortens your life. All right, here's the last example. So evaluate the definite integral from negative pi by 4 to what? Pi by 4. All right, so that is our f of x is what? X cubed plus x to the 4 tangent of x. So let's see whether it is odd or even. Now, f of negative x, we have minus x to the cube plus minus x to the 4 times tangent of my negative x. Now this gives me minus x cubed plus, okay, this will be x to the what? 4 times minus tangent of x, all right? So you have minus x cubed minus x to the 4 tangent of x, which is the same as minus, bring the negative out, which is x cubed plus what? X to the 4 tangent of x. Now what is this? This is my what? F of x. So this is equal to minus f of x. Therefore, f is what? Odd. Now if f is odd, then it means that the integral from negative pi to what? From negative pi to pi by 4 to pi by 4 of whatever is there, x to the 4, then tangent of x. I don't need to do anything at all. Once I conclude that it's odd, this is equal to 0, period. You're done. Okay? All right. So I believe that is the end of this section, and I'll see you in class soon. Thank you. Bye.